let's get fixing those small issues that we had in the last lecture. The issue with the little hop here at the end, the issue with sliding down slopes when we're not pressing anything, and the issue where we kind of stop at the start. So basically we're going to have 3 small changes that we will make to our move function. And each of these changes is basically a little bit of a hack built on top of the move and slide with snap to get this working nicely. And once again, since this is a beginner course, I felt that it was best to do this method. And honestly, it was pretty easy to implement and works quite nicely in the game. So the first thing we need to detect, okay, so let's talk about the methods here a little bit. So, and which problem we're going to solve. Let's solve the easiest one. The easiest one to solve is actually this little hop here. And the way we can fix that is by checking to see if we just left the ground. And if we did just leave the ground, then we can set our y value to 0. However, the only time we don't want to do that is if we are pressing the jump button like this. So we can say, did we just leave the ground and did we just jump? Those are the questions we're going to be asking. And if both of those are true, or if we didn't just jump and we just left the ground, we want to set our y value to 0, our motion.y. If we did just jump, then we don't want to, and if we didn't just leave the ground, then we don't want to. And that's how we're going to solve the problem. So first, how are we going to detect if we just left the ground? Well, we want to check to see if we are on the floor. And then in the next frame, not in the next frame, but after moving, we want to check if we are now in the air. So we'll say var was on floor equals is on floor. And order here is crucial. We have to do this check before we actually move, because if we do it after, then it will be checking to see if we're on the floor after we've already moved. We need to check before we've moved, then we move, and we can check again to see if we're in the air. So this is how we're going to do it. We'll say if was on floor, so if we were on the floor, and not is on floor. So if we were on the floor and now we're no longer on the floor, we know that we just left the ground, because before moving we were on the floor and now we're no longer on the floor. So, but we have to create the variable for just jumped. So we'll just create a Boolean variable up here, var just jumped equals false. And then when we, every single frame, so up here at the very top of our physics process, we're going to set just jumped equal to false. However, when we actually jump right here, if input.isAction pressed, right here we'll set just jumped equal to true. And once again, order here is important. We set it to false at the start of the physics process, but if they press the jump button, then it will be true, and then down here we will know. If they press the jump button, then just jumped will be true. If they didn't press the jump button, then just jumped will be false. So order's important there. So then we can say and not just jumped. We can set our motion.y equal to motion.y equals 0. And just jumped, oh, it looks like I have a typo here. Jumped, there we go. Got an error message there. We'll run the game and see how this works, okay? And you can see we leave the ground. Looks pretty good. We don't have that little, there does seem to be a tiny bit of a hop still. And so what I did to fix that, it's very minor, so maybe you don't want to do this, but maybe you do. I actually get our last position up here. Var last position equals position. And then down here I just say position dot y equals last position dot y. And that sets our y value to be the same as it was before we left the ground. And then it seems to fix that tiny bit of a hop that's there. But we can still jump just fine. Great. That's one glitch fixed. And, well, glitch is a rough word. It's not necessarily a glitch. It's just the way that the code interacts. So that's one thing fixed there. And we're going to fix the next one. So let's fix the landing because that one's actually pretty easy as well. So we're going to create another variable up here called var was in air. This will be equal to not is on floor. And that's a little bit of a double negative, but if we're not on the floor, then we are in the air. And then down here, above, and I'm going to use comments here actually. So this one is just left ground. And I'm going to put a comment here called landing. So this is going to happen when we land. If was in air and is on floor. So it's basically the opposite of what we have here. If we were on the floor before, but now we're not on the floor, then we left the ground. If we were in the air before, but now we are on the floor, then we just landed. So it's kind of the opposite of what we did before. Then we just set motion.x equals last motion.x. So this will remember our previous x motion, or last position.x, actually. No, it should be motion. Motion. We have to grab our last motion as well. Var last motion equals motion. So this is our motion before it gets affected by the move and slide function, because the move and slide function takes our motion and changes it and spits it back out right here, different than it was before. So we're going to get that previous motion value, basically the previous x speed that we had before, and we're going to set it again down here right every time we land. So right when we land, it'll do it. Sometimes it's just not going to do anything because we'll be landing on flat ground, so then the motion will be the same. However, if we're landing on a slope, this will make sure that we keep our previous momentum and we don't lose it like we were before. And you can see now we no longer have that awkward kind of stopping right when we land. We still have the sliding. We'll fix that in just a minute. But this fixes a lot of our problems already. And it feels much, much smoother. The sliding is honestly just annoying. And this is probably, out of all these fixes, the sliding fix is probably the most hacky. So I do hope that in the future, they can figure out how to get stop on slope and snap to work together. And maybe there's something that I could do to get it to work now, but I was unable to find that. So if you guys know, let me know. Now let's do our last one here. Prevent sliding. And we'll just put a little comment here that this is definitely a hack. We'll say if is on floor. So, well, let me explain the logic for this. Basically, we're going to check to see if we're on the floor. And then we're going to check to see the floor's velocity to make sure that the floor isn't moving. And that's important because we will have moving platforms, and so we don't want to apply this when we're on a moving platform. So the one thing to know is that you can't have sloped moving platforms, but that's probably not going to be an issue for most people. I don't know why you would have sloped moving platforms. So, well, there are sometimes times that you might want to, but so we want to check to make sure that the floor isn't moving, and get floor velocity dot length equals 0. So if we're on the floor and the floor isn't moving, and the absolute value of our motion dot x is less than 1, that means our motion is just very, very tiny, right? Because as we're sliding down it, the motion is really tiny. Then we just want to set our position dot x equal to our last position dot x. So it just says, oh, put us back where we were before. Don't let us move, basically, if our motion is so tiny. And you can see that works. We no longer slide on slopes. And so I think this is a pretty good solution to get nice sloped movement inside of Godot. And I'm pretty happy with how it turned out in the end, even though it has a couple little hacks. You guys will have to tell me if you like it as well. Thank you so much for watching this lecture. Hope you enjoyed it, and I will see you all in the next one.